sigma r is equal to 1 to 25 r by r power 4 plus r square plus 1 is equal to p by q, where p and q are two integers, positive integers, such that their GCD is 1. Then what is p plus q only we should find. Okay, observe this first of all. Let's simplify in a proper way. R by r power 4 plus r square plus 1, right? Now r by, from these two terms can you take it as common r square? Now what is the remaining? R square plus 1 is there. Okay, now to take common r square plus 1, actually here r square is required, so you can add one r square and we can subtract one r square like this. Now what happens? See, r by, from r square plus 1, if we can take it as common from up to here r square plus 1 taking common is remaining r square only, and from this if you take r square plus 1 completely common is plus 1 only, minus r square we will get it. Okay, now clearly it is what now? R square plus 1 whole square, r square plus 1 whole square minus r square. Now how can you write this one? R by a square minus b square formula we can apply, then we will get r square plus 1 plus r into, see, r square plus 1 plus r into r square plus 1 minus r we will get it. Okay, a square minus b square formula we applied. Now if you observe the denominator, two terms are there, their difference is exactly 2r. Here plus are there, here minus r is there, remaining term as it is, right? So their difference is 2r. If you can make it the difference as numerator, then we can get difference of these two terms clearly. So 2r is required. For the purpose we can multiply and divide with 1 2. Now numerator is 2r only, that 2r we can write the difference of these two terms, r square plus 1 plus r minus of r square plus 1 minus r by r square plus 1 plus r as it is, r square plus 1 minus r as it is, right? Now if you split this one as two terms, then what we will get? 1 by 2 of this is by this one means this is the term going to cancel, r square plus 1 plus r cancel, the remaining is what? 1 by r square plus 1 minus r is the leftover first term, minus second term is what? When you cancel the r square plus 1 minus r, remaining is 1 by r square plus 1 plus r. Okay, like this we got it. Now here it is can you convert this complete in terms of r plus 1, so that we can get it one relation here. See, here r square plus 1 plus r is there, right? I want to write every place of r as r plus 1. How it is coming? Check it. R plus 1 whole square we can write first of all. Now when you are expanding this r square plus 1, both terms are matched up, but 2r will come, but here r only is there, so that's a minus r we can take it to make the balance. Clear? Now this is the one I am writing again, r plus 1 whole square. In terms of r plus 1 only, we want to get it, so minus 1 plus 1 we can do it now. So what happened now? R plus 1 whole square, this plus 1 I am writing as it is, and this from this minus taking count means r plus 1, right? So the entire thing we can write like this, 1 by 2 of 1 by, this is the term as it is we can write, minus, now r square plus 1 plus r means we also can write like this. See, r plus 1 whole square plus 1 minus of r plus 1. Okay, now why we wrote like this means to form a proper pattern. See, when you take it is f of r, clearly every place of r plus 1 is there, it will become f of r plus 1. So 1 by 2 times of, let us take it is f of r function in r minus definitely it is function in r plus 1. Okay, every place of r is r plus 1 is there, right? Now what we should find? Actually sigma only we should apply. From r is equal to 1 to 25, apply the sigma now. So sigma r is equal to 1 to 25, we are applying. This complete term means what? This is only now, for this only we should apply. However 1 by 2 is constant, we can take it outside, 1 by 2, and for this only we should apply f of r minus f of r plus 1. So when you are applying the sigma here, what happens? See, 1 by 2 of, when you put 1 in the place of r, f of 1 minus f of 2 we will get. Okay, plus when you put in the place of r as 2, we will get f of 2 minus f of 3, plus and so on. When you substitute last 25 here, what we will get? Plus f of 25 minus f of 26 we will get it. Okay, now middle terms definitely going to cancel like this, and even for this previous what we will get now, f of 24 minus f of 25 only, that minus f of 25 plus f of 25 is going to cancel. Now only 1 by 2 times of f of 1 minus f of 26 is the only left over, right? Now we have to calculate this one only. So what is f of 1, what is f of 26, we have to calculate. So calculate now. What is f of 1 actually? What is f of r? We have f of r is very clearly, we already took no 1 by r square plus 1 minus r, right? This is only our f of r, right? Now f of 1, f of 26 we should find. F of 1 means how much? So 1 by 1 plus 1 minus 1. So 1 1 cancel, we got the result is 1. F of 26 is what? 1 by 26 square. 26 square plus 1 minus 26, right? So 1 by 26 square we have to calculate. So 26 into 26, 6 6 are 36, 6 2 are 12 plus 3 15, 26 2 are 52, 6 7 6 676, right? That 676 676 minus 26 minus 25, 1 minus 26 minus 25, minus 25, do it. What happened now? 6 minus 5 1, 7 minus 2 5 and 6, 651 we will get denominator. Okay, finally what we have to do? From f of 1 we have to subtract f of 26 only now. So what happened? Final our result is 1 by 2 of f of 1 means 1 minus f of 26 means 1 by 651. Now take LCM. When you take LCM, 651 now, 651 minus 1, that means 650. So 1 by 2 times of 650 by 651 we will get it. Okay, now finally it is cancellation possible with 2 del because it is even number only now. So 650 lo half, so how much we will get? 325, right? So 325 by 651 we will get it. Okay, now least form it is only we have to check it, right? Is there any cancellations is possible, Ani? So logically we can say the GCD is 1 only because here 650 651 both are consecutive numbers, no? So in this half only now it will be, so definitely these two are what now? Co-prime numbers. Now sum of these two only our answer, right? So 325 plus 651, 976 we will get. Okay, so our final answer is what now? 976. Okay, 976.